Hello friends, welcome back. Let's continue our journey in the branch and bound algorithms. Now it's time to see how a 0-1 knapsack problem can be solved using branch and bound. So basically this problem is a maximization problem, whereas the branch and bound is for minimization problem. Therefore we need to convert maximization problem into minimization problem before using the branch and bound. So the easiest way of doing that is negate all the profits. So the minimum of a negative values will be a maximum in the positive sense. So like if we have 12 and 18, and if you can find out only minimum, not maximum, but we want maximum to be found out, then better you make it negative of that, and then you will know that minus 18 is smaller than minus 12. So our minimization algorithm says that minus 18 is smaller than minus 12, and after this is done, again negate back the answer to plus 18. So that's a simple logic we can look for. Okay, so we are working with this old knapsack problem we worked earlier in greedy method, dynamic programming, all that. Same problem we'll continue and try to see. So there are four items with profit 10, 10, 12 and 18 respectively, and their respective weights are 2, 4, 6 and 9, and we have a knapsack of capacity 15. So we are interested in finding what all can be put into knapsack. So it is 0-1 problem, that means either put it totally or leave it totally. So that's logic we talk about. So we want to use branch and bound, and in the branch and bound there are three methods. So let us look how this problem can be solved using least cost method. In this we have two things. One is called the cost, that means the total profit with the full bag, that means fractions allowed. But the upper bound is something to do with without fraction, what will be the profit. So these two things we keep looking. So to begin with, we don't know what is selected and all. So what is total cost possible? So we can take the first item, that makes 2 units of weight. Then we can take minus 10 as a second item, so that makes 4 units. And then we have the next item, which is of size a profit of 12, and this has got a size of 6. Now we are left with 2 plus 4 plus 6, 12, and we are left with only 3. So the fourth item, we can add only 3 units of that, so 3. So the cost of this will be minus 10, minus 10, minus 20, minus 32 and minus 6, so that makes minus 38. Then in reality this cost cannot be added, so this is minus 10, minus 10, minus 12, that is minus 32. So this is talking about using all the 4 items and working on that. So let's see what happens if x1, that is the first item, is used or not used. If it is used, we don't find any change, because in the first case we have assumed that it is used. So if you don't use first item, then we are left with the second, third and fourth. So second item can make it 10, third item can make it 12, and these two are totally making 10 units of weight. So we are left with 5. Therefore, the third one can have only 5 units. So that makes the cost equal to minus 22 minus 10. So that is minus 32, whereas the upper bound will be without fraction minus 22. Now we are working on least cost. So this is minus 32, this is minus 22. Therefore, minus 32 is smaller than minus 22. So we continue this. So here we say x2 equal to 1, x2 equal to 0. Then when x2 is 1, x1, x2, all 4 were considered. Therefore, this is going to be minus 38, minus 32 as it is. Whereas this side is going to change. First one is considered, second one is not considered, third, fourth are available. So from the first one you have minus 10, from second one we don't consider, from third one we have minus 12, and the fourth one we have a fraction. So first one and third one, they are making 8 units. So we are left with another 7, so that you can make it. So that is 14 plus 12 minus 26 plus 10 minus 36 we have. That is the cost, whereas upper bound without this is minus 22. Okay, that is minus 32 here, minus 22 here, minus 22 here. So it is now time to expand this one. So this is minus 38, minus 32, and this is for x3 equal to 0. This is x3 equal to 1. So if you don't consider x3, then this is minus 10, minus 10, minus 18 by 9 into, this is 6. So we are left with 9. So that is, you have to consider 2, 4 and 6, all 15 are considered. So that makes C is equal to minus 38, and no fraction was used. So this is also minus 38. So x3 0 will give minus 38. So this is minus 32, minus 38, minus 22, minus 22. So the next option is to expand this one for x4 equal to 1, x4 equal to 0. If x4 equal to 1, it is going to be minus 38 as it is coming from this. But if x4 is 0, then first one is there, second one is there, third and fourth are not there. First is there, second is there, third and fourth are not there. So that makes 20 and 20. So that completes. So we have 38 here. So this is 32 here. This is my 20 here. This is 22 here. This is 22 here. And we find that the least one is this minus 38. Therefore, that minus 38 is the answer. So 38 is the maximum profit we are going to get. And that is possible with x1 equal to 1, x2 equal to 1, x3 equal to 0, and x4 equal to 1. So that's how this problem can be solved using a least count. Yeah, the same problem can be solved using first in first out as well as first in last out. We can see these two solutions in our coming sessions. So till then, take care. Bye.